In this section, we are going to discuss about the carbon nanotubes, abbreviated as CNT. The CNT can be formed by roll-up of a graphene sheet. The structure of carbon nanotubes is formed by rolled up graphene sheet in a cylindrical pattern. For example, if we take this is a graphene sheet, it can be rolled up and form as a cylinder. This tube is known as carbon nanotubes or CNT. The graphene is nothing but a layer of carbon atoms that are bonded together in a hexagonal mesh. That is a thickness of one atom of carbon formed in honeycomb shape as in the figure. Let me explain the different classification of carbon nanotubes. Initially, the single-walled carbon nanotubes, SWNT, and multi-walled carbon nanotubes, MWNT. In the case of single-walled carbon nanotubes having a single outer wall of graphene sheet. In MWNT, nanotubes having several coaxial tubes, that is with the multiple walls. In addition to that, we can classify the CNT further by its structure. By rolling the graphene sheet above the T vector at different orientation, three different CNT structures can be obtained, namely zigzag, armchair, and chiral. The rolling vector with an angle of theta equal to 0, theta equal to 30, and between 0 and 30 as in the figure. These are all the major classification of CNT. Let me explain the different properties of carbon nanotubes. Regarding the properties, just we start with the mechanical properties. The carbon nanotubes has amazing mechanical properties due to highest strength of carbon-carbon bonding. The tensile strength or breaking strength of a carbon nanotube can be 63 gigapascal, around 50 times higher than steel. Regarding the electrical and thermal properties of CNT, the carbon nanotubes can be act as a metallic or semiconductor depending on their structure during the preparation. In the case of armchair structure, the nanotubes have conductive higher than that of a copper. In the case of chiral structure, the carbon nanotubes behave more like a silicon. The thermal conductivity of a carbon nanotube is 10 times that of silver. This is the property of thermal property. In the case of CNT, the conductivity is by means of the vibration of covalent bonds between carbon atoms. Regarding the chemical properties, the structure of CNT generated with a certain size provided high chemical reactivity. Because of the miniaturization of the size in nano size, the surface area is very high, so the reactivity will be very high. These nanotubes with a smaller diameter results in increased reactivity with the different reactants. So regarding the application of CNTs, the CNT has a diversified potential applications. We will discuss some of the application here. The first, field emitting device application. The electron emission of CNT at a small amount of applied electric along the axis of a nanotube is very high. This emission is known as field emission. This electron emission of CNT is used in electronic industries like flat panel display. Another application is the energy storage. The carbon nanotubes have been used as a large storage device in battery, fuel cells, etc. We are very familiar, the lithium are used as a charge carriers in batteries, so that the lithium can be stored in a carbon nanotube. CNTs can store hydrogen in the inner cores through a capillary effect. Another application in the computers, the CNTs are used as a connectors in computer industries. For miniaturization of computers, the CNT can carry a large current without any heating, so that the CNT can be used as a connector in mini computers. We will discuss some other application. In that case, the CNT finds a wide utilities in different industries. The CNT have been used to develop artificial muscles. The CNT can be used as a chemical sensor to detect the poisonous gas like nitrogen oxide. Similarly, the CNT can be used in medical field as a drug delivery system. So these are all the some of the application in CNTs. So in this section, we discussed what is CNT, what are the structure of CNT, what are the properties of CNT, and some of the applications of CNT. Thank you.